carrying on with the enthalpy profile diagram information, we've got one that's already pre-drawn that you've probably done in a previous question for 3 marks. So now the other parts of the questions, they tend to ask you to do some calculations based on the information given, and they can vary between 1 and 2 marks. So we're just going to do a couple of examples. So here we've got an endothermic reaction profile. The arrow is going up. We've got a positive value, okay, and the reactants are starting lower than the products. So here the question is, what is the enthalpy change of formation for HI gas for 1 mark? So here you notice in this reaction diagram we've got 2 moles. The definition for enthalpy change of formation is the formation of 1 mole of substance. Okay, 1 mole. So what we need to do to get this into 1 mole is the value they're giving you for delta H plus 53. So we have 53, and to get into 1, 2 into 1, you just divide by 2. So we divide that by 2. So 53 divided by 2 is 26.5 from my recollection. So 26.5 kilojoules per mole. Okay, for the formation of HI. So just beware that you don't just give this value here. You've got to look at the number of moles, and if they're asking you for the enthalpy change of formation, and this is in 2 moles, you've got to divide the number given to you here. So what is the value for the activation energy for the reverse reaction? Now this is one that came up on our mock exam and tripped people up. So the reverse reaction, so the activation energy for the forward reaction is plus 183. But in this instance, we are wanting to go the reverse direction, okay? So our activation energy is not going to be as high. So we've got 183. It's not going to be as high, so we need to take some off. So whatever value they've given you here, so do 183, take 53. And that is, from my calculator, 130 kilojoules per mole. Now have a go at this reaction example here, but just beware it's an exothermic reaction. Have a think and see if you can come up with the answer to this. So just pause the video now, and then I'll go through the answers in a minute. Right, okay, so here we've got an enthalpy profile diagram for the exothermic reaction for the formation of ammonia. Again, we've got it labelled, the arrow's going down, it's delta H. We've got our activation energy labelled. The products are lower than the reactants. So what is the enthalpy change of formation of ammonia? Okay, so the enthalpy change of formation of ammonia. So delta H is minus 92. Okay, so 2 moles of ammonia. So all we need to do is 92 divided by 2. And that's 46. So 46 kilojoules per mole to the minus 1. So this time, okay, so that's just for the 1 mole, oh sorry, minus as well, minus 46 kilojoules per mole, because this value here is minus. So the next one, what is the value for the activation energy for the reverse reaction? So that reverse reaction going from this one to this. Remember, if we're going from reactants to products and the products are higher, the activation energy must be larger. Okay, so this time, rather than taking like we did in the endothermic one, the exothermic, you must add them together. So 250 add 92. 250 add 92. Let's have a look. It's 342. 342 kilojoules per mole. Okay, that value has to be larger. Value's got to be larger because we're going from this to this. We've got all that for the activation energy this time, so just be aware of that in exams.